Okay, Unit 9 problem review. This will walk you through one of each type of problem. First type, mole to mole. The reaction is zinc plus 2 hydrochloric acid produces zinc chloride plus hydrogen gas. Question, how many moles of hydrogen are produced from the reaction of 3 moles of zinc with an excess of hydrochloric acid? We never worry about excess. We want to know moles of hydrogen. That's my unknown. We know moles of zinc. Mole to mole is a one-step problem. So I draw my grid. I put what I know in the first box, 3 moles of zinc. I put my mole ratio in the second box. Coefficient of the unknown, invisible 1. Coefficient of the known, invisible 1. 3 times 1 divided by 1 is 3 moles of hydrogen. Next type, mass to mass. The chemical equation. Nitrogen plus 3 hydrogens make 2 ammonia. Question says, how many grams of ammonia are produced when 35 grams of hydrogen is reacted with excess nitrogen? We'll cross that part off. We want to know how much ammonia. We know how much hydrogen. So there's my K and my U. Draw my grid. 1, 2, 3. I'm going to fill in 1 mole here. I'm going to fill in 1 mole here. So we know that we have 35 grams of hydrogen. What's the molar mass of hydrogen? Hydrogen is H2. Hydrogen weighs 1. 2 times 1 is 2. I'm going to put my mole ratio right here. Coefficient of my unknown is 2. Coefficient of my known is 3. And I'm going to finish up with my molar mass of ammonia. Nitrogen weighs 14, plus 3 from the hydrogen, that's 17. Notice I have a 2 and a 2. I'm going to cancel them so I don't have to deal with them. And the math that I have to do, 35 divided by 3 times, 35 divided by 3 times 17. And I find out that I should make 198 grams of ammonia. Next one, volume to volume. Propane plus 5 oxygens makes 3 carbon dioxides and 4 waters. If 20 liters of oxygen, that's my known, are consumed in the above reaction, how many liters of carbon dioxide, that's my unknown, are produced? Draw my grid. Fill in my 2 1 moles. Put my known in the first box. Now the conversion for moles to liters is always 22.4. So the only thing I need to figure out is my mole ratio. Coefficient of my unknown is 3. Coefficient of my known is 5. Notice my 22.4's cancel. 20 times 3 divided by 5. I would make 12 liters of carbon dioxide. For the last one, the mixed, we're going to use our twin mole cities. In our reaction, 2 aluminum chlorides are producing 2 aluminums and 3 chlorines. Question says, if 10 grams of aluminum chloride are decomposed, how many molecules of chlorine are produced? So we're starting at mass, we're finishing at particles. I'm going to fill in my 2 1 moles, put my known in the first box, 10 grams. Notice as you go from mass to moles, you go over molar mass. This is my known, this is my unknown. How much does AlCl3 weigh? Aluminum weighs 27, chlorine weighs 35.5, and I'm going to add that 3 times. So this weighs 133.5. Here's my mole ratio. Coefficient of my unknown is 3. Coefficient of my known is 2. Now if I go from moles to particles, the number that I go over is Avogadro's number. 6.02 times 10 to the 23rd. So when I work this out, 10 divided by 133.5 times 3 divided by 2 times 6.02 second EE 23. And I find out that I would make 6.76, I'm going to round that to 6.8 times 10 to the 22nd molecules. Okay, last two things, finding the limiting reagent and calculating percent yield. If you look at this reaction, 2 aluminums plus 3 copper chlorides produces 3 coppers plus 2 aluminum chlorides. A sheet of aluminum foil is placed in a blue solution of copper chloride. At the conclusion of the reaction, the solution in the beaker is clear and you can see copper metal and aluminum foil floating in it. What was the limiting reagent in it? This is not a math question. Well, we knew that the copper chloride was a blue solution and it's now gone because it's clear, so we know there's no more of this. And we can still see aluminum foil, so this is left over. So what did we run out of? We ran out of copper chloride. That's our limiting reagent. Now, percent and theoretical yield. In this reaction, we have silicon dioxide plus carbon, making silicon and carbon dioxide. Question is, what's the theoretical yield of silicon if 1,000 grams of sand is reacted with excess chlorine? So we know how much sand, we want to know how much silicon. Now remember, theoretical yield is just mass-to-mass stoichiometry. So we're going to do it the same as we've done those. 1 mole on top, 1 mole on the bottom. We know that we have 1,000 grams of our sand. What's the molar mass of sand? Silicon has a molar mass of 28 plus 16 has a molar mass of 60. Coefficient of our unknown is 1, coefficient of our known is 1. And then when we go to leave, the molar mass of silicon is still 28. So the math on this, 1,000 divided by 60 times 28. 466.7 grams. That's how much we should have produced. Now what's the percent yield of the above reaction if we only make this much? This is our actual. This is our theoretical. Percent yield equals actual over theoretical times 100. So I'm going to put my 300 over my 466.7, and I'm going to find out that this reaction was 64% yield. Good luck on the test tomorrow.